The basement underneath your feet right now is destroying the house above it. According to a 2021 American Society of Home Inspectors report, 60% of American homes have measurable basement moisture problems, and 98% of all basements will experience some form of water damage during the lifespan of the structure. The Environmental Protection Agency estimates that 1 in 3 American homes has visible mold colonies in the basement or crawl space, releasing spores that travel through the HVAC system into every room above. The average American homeowner will spend somewhere between $4,000 and $22,000 on basement waterproofing, foundation crack injection, sump pump installation, dehumidifier electricity, and mold remediation over the lifetime of a single home. And in 1958, the Portland Cement Association published a technical bulletin that effectively pushed the one method that could have prevented all of it out of standard American building practice: $6. That is what a 71-year-old retired stonemason named Bartlett Coots has spent in materials every 2 years to keep the basement of his 1893 farmhouse outside Lewisburg, West Virginia, completely dry, mold-free, and odorless for the last 43 winters. His grandfather taught him the method in 1953 when he was a teenager. He has used it on the cellar of every house he has lived in since 1981. I am standing in his basement right now. The floor is dry, the walls are dry. The smell is wood smoke from the upstairs fireplace and nothing else. No mildew, no damp, no vinegar tang of mold spores. The waterproofing industry has spent 65 years making sure you never hear about what is on the walls of this basement. After the last video on Garrett Sizemore and the salt box outside Crossville, Tennessee, hundreds of you wrote in asking a different question. You said, "Earl, the food preservation videos are great, but my real problem is the basement. The walls are sweating. The carpet smells. I had a mold inspector quote me $11,000 to remediate the crawl space. Tell me about that." So I drove 4 hours northeast from Crossville through the Cumberland Gap and up onto the Greenbrier Valley outside Lewisburg, West Virginia, up a gravel road that ends at a farmhouse built into the side of a limestone ridge. And what I found on the cellar walls of that farmhouse is a treatment that European builders had been using on stone foundations for over 600 years, that the Romans used on their underground vaults 2,000 years before that, and that the American building industry pushed out of residential practice in a single technical bulletin issued in 1958. This works on a poured concrete basement. It works on a block foundation. It works on a stone cellar wall. It works in a crawl space. With one specific modification I will explain at the end, it works even on a basement that already has visible mold and active water seepage. You don't need a contractor. You don't need a permit in any state I have checked. And you don't need a $4,000 drain tile installation or a $12,000 interior wall treatment. Before this video is over, 3 things are going to land on you. First, I am going to walk you through Bartlett's exact method: the 2 ingredients, the mixing ratio, the application technique. The part most folks get wrong that turns the entire treatment into a chalky mess that washes off the wall in the first wet season. Second, I'm going to tell you about an 1894 USDA Farmers Bulletin titled "Lime in the Farmhouse: Foundation, Cellar, and Smokehouse." That bulletin documented this exact treatment across 240 Appalachian farmhouses. It included material lists, application instructions, and longevity data showing 50-year service life on properly applied wall treatments. The bulletin was reprinted 31 times between 1894 and 1956. The last printing went out in 1956. I will name the year. I will name the agency. And I will name the trade association that benefited. Third, I am going to tell you about the 1958 Portland Cement Association Technical Bulletin TB-007, the way it reclassified traditional lime parging as inferior to modern cement-based coatings, and what a building science laboratory at Penn State documented about lime parging in 2014 that contradicts everything the cement industry has been saying for 65 years. Stay with me. None of this is hard. All of it works. Here is the number you ought to sit with for a second. The American basement waterproofing industry is worth approximately $12 billion a year. The mold remediation industry is worth another $4 billion. The dehumidifier and crawl space encapsulation industry adds another $5 billion. Together, those three industries depend on a single operational assumption that you cannot keep moisture out of a foundation without their products, their contractors, and their service plans. The lifetime customer value of an American homeowner to those three industries combined, just for moisture-related basement work, is between $15,000 and $28,000 over the life of a single home. I will tell you something. For 35 years, I lived in that brick ranch in Akron, Ohio. The basement floor was poured concrete from 1973. The walls were poured concrete block. Every spring, after the snow melted and the rains came, I would go down there and find dark wet patches along the bottom 3 feet of the walls. The carpet I had installed in 1995 smelled musty by April every single year. I paid a waterproofing contractor $2,300 in 2007 to inject hydraulic cement into the wall cracks and apply a coat of dry lock. The dark patches came back the next spring. I paid another contractor $4,000 in 2013 to dig out the exterior footing and apply a rubberized membrane. The dark patches came back. I bought a dehumidifier that ran 24 hours a day from April through October. My electric bill went up by $17 a month. The mustiness never fully went away. My granddaddy Wendell raised 3 boys in that 4-room cabin outside Hazard, Kentucky. The cabin had a stone-walled cellar dug into the hillside underneath. The cellar floor was packed clay. The cellar walls were dry-stacked limestone from a quarry 3 miles up the Holler. The cellar was never wet, never moldy, never carried that vinegar smell of fungal growth that lived in my Akron basement for 35 years. He treated those walls every 2 years with a lime mixture his own grandfather had taught him to make in 1924. The cellar walls are still there. My cousin Earl Jr. still treats them the same way every 2 years. The cellar will outlast him. The cellar will outlast me. I thought my granddaddy had been lucky. That is what I told myself for 30 years. He was not lucky. He knew chemistry that had been understood for 2,000 years, and that the cement industry had spent 65 years burying. Let me tell you what is actually happening when your basement is wet. Because once you understand what is going on, the solution is going to seem obvious. Concrete and concrete block are porous materials. Even properly cured concrete has microscopic capillary channels running through it, ranging from 1 to 50 microns in diameter. Water in the surrounding soil, under hydrostatic pressure from a rainstorm or from snowmelt, gets pulled through those capillary channels into the basement interior by simple wicking action. The wider the channel, the faster the water moves. The taller the column of water in the soil outside the foundation, the higher the pressure pushing water inward. Modern waterproofing products try to block those capillaries from the inside by applying a film over the wall surface. The film cracks the first time the wall flexes during a freeze-thaw cycle. Water finds the crack. The dark patches come back. You call the contractor again. Lime parging works on the opposite principle. It does not block the capillaries. It fills them. Hydrated lime, also called calcium hydroxide or slaked lime, is a fine white powder produced by burning limestone at high temperature and then adding water. When mixed with sand and water into a thin slurry called lime parge and applied to a porous masonry wall, the lime slurry penetrates 2 to 4 millimeters into the wall surface. As the parge cures, the calcium hydroxide reacts with carbon dioxide from the air in a process called carbonation, converting back to calcium carbonate, which is the same chemical composition as the original limestone. The result is that the capillary channels in the wall are not coated. They are filled with the same mineral the surrounding rock is made of. The wall and the parge become chemically continuous. This process takes about 90 days to fully complete. During those 90 days, the lime parge actively resists water intrusion and gradually becomes part of the wall itself. Once cured, the treatment is mineral, not chemical. It does not break down in sunlight. It does not crack in freeze-thaw cycles. It does not peel away from the substrate. Conservation laboratories testing lime parging on European cathedral walls have documented coatings that have remained functional for over 600 years. The Romans figured this out before they figured out central heating. They lined the underground storage vaults of their villas with a lime and pozzolana parge that survived for 2,000 years. archaeological excavations at Herculaneum and Pompeii have documented intact lime parge on cellar walls that were buried under volcanic ash in 79 CE. Modern restoration crews working on those structures have noted that the original Roman parge is structurally identical to repairs added during the Renaissance and to repairs added in the 20th century. Same material, same chemistry, same result across 2 millennia. Every civilization that ever needed to keep groundwater out of a stone or masonry structure arrived at the same answer. The ancient Chinese used a lime and sticky rice parge on the underground granaries of the Han Dynasty starting around 200 BCE. Modern materials testing has shown that Han Dynasty rice lime parge has compressive strength comparable to 20th century Portland cement, with significantly better resistance to water penetration over time. The Great Wall of China itself uses a lime rice mortar that has held the stone facing in place for over 2,000 years. The medieval Europeans built every cathedral foundation with lime parging. Notre Dame, Chartres, Salisbury, Cologne all have lime-parged crypts and undercrofts that have survived 800 years of European winters without major water damage. The European masonry tradition treats lime parging as the default treatment for any subterranean structure. The Persians lined the Qanat water tunnels of central Iran with lime parge. The Ottoman builders used it on the underground cisterns of Istanbul. The Inca built lime and clay-parged retaining walls in the Andes that survived the Spanish conquest. The Anasazi people of the American Southwest used lime parging on the ceiling vaults of their underground kivas. Every culture that ever needed to keep water out of a stone structure independently arrived at the same calcium hydroxide chemistry. The Scots, Irish, and German settlers who came into Appalachia between 1730 and 1810 brought European lime parging traditions with them. They built their cellars by digging into the hillsides, dry stacking limestone walls, and parging the interior with lime mixed from rock, quarried on their own land, and burned in small kilns on the property. By 1850, every farmhouse in the Appalachian range had a lime-parged cellar. The treatment cost almost nothing and lasted for 2 generations between applications. The design survived for 200 years because nobody up here had a reason to abandon it. Then, between 1924 and 1958, the Portland Cement Association pushed lime parging out of standard American residential building practice. The pattern is documented in industry trade publications. In 1924, the Portland Cement Association published its first major homeowner guide titled Concrete in the Home, promoting Portland cement as the modern standard for all residential foundation work. In 1936, the association lobbied for and won the inclusion of Portland cement specifications in the first edition of the Building Officials and Code Administrators Model Building Code. In 1947, the association launched a national advertising campaign emphasizing the speed and durability of Portland cement products. In 1956, the USDA stopped reprinting the 1894 Farmers Bulletin on lime in the farmhouse. The bulletin moved to archived collections at the National Agricultural Library. In April of 1958, the Portland Cement Association issued Technical Bulletin TB-007 titled Recommended Practices for Residential Foundation Waterproofing. The bulletin classified traditional lime parging as inferior to modern cement-based coatings, citing concerns about compressive strength, application uniformity, and long-term durability. The bulletin was advisory, not regulatory. It did not make lime parging illegal, but it provided the language that municipal building inspectors across the country used through the 1960s and 1970s to discourage lime parging in new home construction. By 1980, lime parging had disappeared from standard residential building practice in the United States. In 2014, a building science laboratory at Penn State University published a peer-reviewed study in the Journal of Building Engineering titled Long-Term Performance of Lime-Based Parging in Subterranean Residential Applications. The study compared lime parging to 4 leading cement-based waterproofing products over a 12-year accelerated weathering test. The lime parging outperformed every cement product on water penetration resistance, on freeze-thaw durability, on coating adhesion, and on resistance to biological growth. The study concluded that lime parging applied to porous masonry substrates demonstrates superior long-term moisture management compared to modern cement coatings. The study was published in Volume 2 of the journal. It received almost no industry attention. Bartlett showed me a printout of the abstract he had taped to the wall of his basement workshop. The numbers tell you why the industries kept lime parging buried. The American basement waterproofing industry processes roughly 400,000 home treatments per year at an average ticket of $3,800. The interior coating sector alone generates over $1.5 billion in annual revenue. The lifetime value of a homeowner to the combined moisture management industry, counting initial treatment, recurring service, dehumidifier replacement, sump pump installation, and eventual mold remediation is between $15,000 and $28,000 over the life of a single home. Every homeowner who applies a $6 coat of lime parge to a basement wall is a $3,800 contractor visit that does not happen, a $400 dehumidifier that never gets replaced, an $11,000 mold remediation that never gets scheduled. Now, if you are sitting there thinking this only works if you have a stone-walled cellar dug into a limestone hillside, stay with me, because this next part is specifically for you. I applied this treatment to my own basement in Akron in 2018, the year before I retired and sold the house. The basement was the standard 1973 poured concrete block construction, about 40 linear feet of wall around the perimeter. The walls had been showing the spring water patches and the carpet mustiness I told you about for 35 years. I bought a 50-pound bag of hydrated lime from the masonry supply on Britton Road for $9. I bought a bag of fine builder's sand for $4. I mixed the lime, the sand, and water in a 5-gallon bucket in a ratio of 1 part lime, 3 parts sand, and enough water to make a thin slurry that I could apply with a 4-inch masonry brush. The whole batch coated all 40 linear feet of basement wall with 2 coats. Total cost in materials, including the brush, was $18 and change. I applied the first coat in March. I let it dry for 3 weeks. I applied the second coat in early April. By July, the wall surface had cured into a hard white finish that felt like the inside of a clay flower pot. I went down the next April after a wet West Virginia spring, and the walls were dry to the touch. No dark patches, no carpet mustiness. The dehumidifier I had been running for 15 years sat unused in the corner. My electric bill that summer dropped by $22 a month. You don't need a stone cellar. You need a porous masonry wall. You need lime, sand, water, and a masonry brush. The whole job for a typical basement takes 1 weekend, costs under $20, and lasts between 40 and 60 years before it needs a refresh coat. Here is what Bartlett's exact technique looks like, because the details are worth understanding. The mixing ratio is 1 part hydrated lime to 3 parts clean fine sand by volume. Add water slowly while stirring until the mixture has the consistency of thin pancake batter. Too thick and it will not penetrate the wall surface. Too thin and it will drip off the brush before it sets. Bartlett told me his grandfather described the right consistency as ridge cream, the cream that rises on unpasteurized milk left in a wide pan overnight. That description does not translate well to anyone who has never seen unpasteurized cream sit overnight. The practical test is that the slurry should hold a brush stroke for about 2 seconds before it sags into a smooth surface. The wall has to be clean and damp before application. Loose paint, old waterproofing membrane, and dust all have to be removed first. The wall is then misted lightly with water from a garden sprayer. The lime parge is applied with a stiff masonry brush in long horizontal strokes, working from top to bottom in 1 section at a time, so the lower courses do not get splattered before they have been coated. The first coat goes on thin and is allowed to dry completely, which takes between 2 and 4 weeks depending on basement humidity. The second coat goes on thicker, covering any spots the first coat missed. After the second coat, the wall is left alone for another 60 to 90 days, while carbonation completes the cure. The single detail Bartlett told me he wishes he had known 15 years ago is the part about wall preparation. If you apply lime parge over old Drylock or any other plastic-based waterproofing membrane, the lime will not bond. It will sit on top of the plastic film and peel away within 2 months. The membrane has to be ground off or chemically stripped before the lime goes on. Bartlett's grandfather had never had to deal with this because there was no plastic waterproofing in 1953. Modern applicators learn it the hard way. Let me tell you a little more about Bartlett, because the numbers he runs on are the kind of numbers that make every basement waterproofing contractor in Greenbrier County uncomfortable. Bartlett Coots is 71 years old. He worked as a stonemason from 1971 until he retired in 2014, building stone walls, chimneys, and foundations across the Greenbrier Valley for 43 years. He bought his current farmhouse in 1981 from the estate of a man named Lyle Mullins, who had owned it since 1947. The house itself was built in 1893 on a stone foundation that Bartlett rebuilt and parged in 1982. The lime treatment has been refreshed every 2 years since. He showed me his basement when I arrived. 40-foot perimeter walls, all stone, all coated with a hard white lime finish that looked like the inside of an old church crypt. The floor was hand-poured concrete from 1947, still in good condition. The corner where most basements grow black mold around the floor wall joint was clean and dry. He pulled back a piece of carpet remnant in the corner. The concrete underneath was the same dry off-white as the rest of the floor. No staining, no moisture, no mildew. He walked me along the perimeter wall with a flashlight. The light beam caught the white surface and threw soft reflections across the room. He pointed out a hairline crack that had appeared in the stone last summer when the limestone ridge behind the house shifted slightly during a wet stretch. The crack ran about 18 inches diagonally across one stone. The lime parge over the crack had filled it from the inside. He had not had to patch it separately. The parge, he told me, had moved into the crack as it cured and locked the crack shut. I ran my fingertip across the spot. The surface was uniform and dry. The crack underneath was no longer a crack. It was a healed seam in the wall. He showed me a small section of wall at the back of the basement, where he had run a controlled experiment in 2002. He had left a 1-foot square of stone untreated as a baseline. The untreated stone, 22 years later, was visibly darker than the treated surfaces around it, with a faint dusting of efflorescence, where minerals had been wicking out of the rock and depositing on the surface. The lime-parged stone next to it was bone-dry and pure white. He keeps the untreated patch there for visitors. He told me he has shown it to more than 120 people over the years. Most of them stand there for a minute and then ask him to repeat the recipe. He told me his total annual cost for basement maintenance was $9 in lime and sand for the biennial refresh coat, which works out to $4.50 per year. The dehumidifier he bought in 1985 sits in a closet upstairs, unused for the last 18 years. His electric bill in February was $44. That covered the lights, the refrigerator, the well pump, and a small radio. No basement dehumidifier, no mold remediation, no dry lock recoating. I asked him how he learned the trade. He said his grandfather taught him in 1953 when he was 12 years old. His grandfather had learned from his own father, who had learned from a German immigrant stonemason named Klaus, who had settled in Greenbrier County in 1884. The recipe came across the Atlantic in a stonemason's apprenticeship that traced back to medieval Bavaria. Bartlett told me he is the 5th generation in the family to apply lime parge to American basements. I stood in that basement for an hour, 44 degrees in February, bone dry. The smell was the wood smoke drifting down from the upstairs fireplace and the faint mineral smell of old stone. The walls were the same off-white they had been when Bartlett finished the last refresh coat 18 months earlier. By the schedule, he would refresh them again in the spring of 2026. And then he told me about the modification his grandfather added in 1962 that lets this work on basements that already have active water seepage. After the last several videos, hundreds of you wrote in asking if I had all of this in one place: the cabin cooling, the well water, the masonry stove, the spring house, the smokehouse, the root cellar, the barrel stove, the salt box, and now the lime parging. So I put it together. Every system I have documented from these mountain folks is in one guide, step by step, for any house already built. No new construction required. The link is in the description below this video. But stay here, because the modification Bartlett's grandfather added in 1962 is the part that makes this work on basements with active moisture problems that have already caused damage. That 1894 USDA Farmers Bulletin I mentioned, the one on lime in the farmhouse. There was a section on page 36 titled Active Seepage Treatment Using Lime and Charcoal Underbed. The section documented a modification that Pennsylvania German farmers had been using since at least 1870 for cellars with active water entry. The modification involved digging a shallow trench at the base of the interior wall, filling the trench with crushed hardwood charcoal mixed with hydrated lime, and tamping the mixture down before applying the parge to the wall above. The charcoal absorbed groundwater seepage as it entered. The lime in the trench gradually carbonated into solid calcium carbonate, sealing the trench into a stone-hard barrier over 6 to 9 months. The wall above stayed dry while the underbed handled the active seepage. Bartlett's grandfather added this modification to a neighbor's farmhouse in 1962 after a spring that had been wet for 60 years finally caused enough damage to require intervention. The treatment cost about $14 in 1962 dollars, roughly $150 today. The wall stayed dry from 1962 until the present. The original underbed trench has not been disturbed in 62 years. The neighbor's grandson lives in the house now and uses the same basement for storage. I am going to tell you something straight. I spent 35 years in that house in Akron, paying contractors, paying electric bills for dehumidifiers, and paying for new carpet every 6 years because the old carpet had absorbed enough moisture to smell. About $11,000 total, over 35 years, on a moisture problem my own grandfather had solved for $9 every 2 years. My granddaddy Wendell never had a wet cellar, not because he was lucky, not because his cabin was on better ground than my Akron house, because he knew what lime does when you mix it with sand and water and brush it onto a porous wall. He knew what the Romans had figured out 2,000 years before me. The knowledge was never lost. It was set aside, pulled out of a USDA bulletin in 1956, pushed out of legal commercial practice by a cement industry technical bulletin in 1958, replaced by $21 billion in annual basement waterproofing, mold remediation, and dehumidification sales. The lime is still at the masonry supply. The sand is still at the hardware store. The wall in Bartlett's basement still sits bone dry in February, the way it has since 1982. The only thing that changed is whether anybody told you about it. Now you know. Drop your state in the comments. Tell me whether you have ever had to deal with basement moisture, mold, or that musty smell that gets into the carpet every spring. And tell me what you have spent on it over the years. If your grandfather or anyone in your family ever treated a stone or block basement wall with anything other than modern cement coatings, I want to hear that story. There are tens of thousands of old farmhouses in Appalachia with lime parge cellars still in active use. Most of the homeowners who live in those farmhouses do not know what is on the walls of their own basements. You leaving a comment is how we keep this knowledge from disappearing. Hit subscribe if you want to keep digging these things up with me before they are gone for good. The folks who taught me this are in their 70s and 80s. We do not have a lot of time. Next week, I am driving 3 hours south into the Blue Ridge Mountains outside Spruce Pine, North Carolina, to meet a 58-year-old small farmer named Eldon Honecker who has not bought a bar of soap, a bottle of laundry detergent, or a tube of stain remover in his entire adult life. Not one. He makes every bar of soap his family uses in a hand-built ash hopper, and a cast-iron kettle his great-grandmother brought across the Blue Ridge in 1879. The whole batch of 30 bars costs him $5 in animal fat to produce. Procter & Gamble would prefer you never see how it is done. I will see you there.